Good morning, everyone. So today is Friday, April 26th. So today you have homework 10.8.1 due, and so today we will continue to finish 10.8. And then next class, we'll see maybe we haven't finished 10.8, then we will continue to finish that. And then we will have a little review about chapter 10. I have already graded your quiz, but let's go over the quiz mistake next Monday. Okay, so I want to finish 10.8 as much as I can. So over the weekend, you can start working on your homework and the practice exam. So I will be in my office today from 11 to 1:50, and also from 3:10 to 5. Even though we don't have a study session, but I have my the tables in front of my office. Feel free to come and work on your practice exam. If you have questions, come inside my office to ask me. Okay, everybody? And also Monday as well. Okay. So any questions so far? No? Okay, then let's continue with 10.8. So last time we talked about vectors, right? If we're giving 2 points P and Q, then to find the vector PQ, we use the terminal point Q minus the initial point P. Right, everybody? And vector has a length or magnitude plus a direction. Okay, so two important concepts, the magnitude and the direction. So how do we find the magnitude? If you have a component form, like V1 and V2, then the magnitude will be the square root of V1 squared plus V2 squared. That is because of the Pythagorean theorem, right? You have x coordinate, y coordinate, then your hypotenuse, the magnitude of the vector is the square root of V1 squared plus V2 squared. And last time we also talked about unit vector. So we have two unit vectors. One is in the same direction. The other one is in the opposite direction. Right, everybody? Unit vector. Unit means the magnitude of the unit vector is 1. Okay? That's why given a vector, how do we find the unit vector? You use that vector v and then divide it by the magnitude of v. Right, everybody? Did we finish number 3 last class? I think you worked on it. And then did we check our answer? Oh, we didn't check our answer. Okay. So then let's check our answers. So we have the v is -2 and 5. By the way, your homework asks you to draw what is v. Then you look at, okay, so you start with the origin. And then your x coordinate is -2. Your y coordinate is 5. So you put a point there and connect to the origin. Right, everybody? This is how you draw the vector. And if your homework asks you to find, what is 3v, or maybe I give you another u, and then you minus 2v, how do you find those? Okay, last time we talked about vector operation. When you use 3 times a vector, you kind of distribute the 3 to each component, right? So you can compute what is the vector 3v in the component form, then you can draw the vector. Similarly, with the u minus 2v, like having like this problem, after you compute the vector, you get the component form. Once you have the component form, you can then draw the vector on the xy plane. Okay, everybody? And then, yes, unit vector. We need the magnitude of v, like a double absolute value bars. So this is the square root of the first component square plus the second component square. And we have negative 2 square is 4, right? 5 square is 25. So we get square root of 29. And I prefer you to learn square root of 29. So don't plug in your calculator and get a decimal. Okay? I prefer to see exact value. And then the unit vector, because it's a find a unit vector. We have 2 unit vectors, one in the same direction, one in the opposite direction. So you just need to find one of them. Okay? But usually we find the one with the same direction. Okay? So then this is V over magnitude of V. V is negative 2, comma 5. Magnitude of V is square root of 29. And then you can move the square root of 29 into each component. Because this is like this guy is like 1 over square root of 29 multiplied by negative 2 and 5. That's why you can distribute. You get negative 2 over square root of 29, bless you, and 5 over square root of 29. Is that okay, everybody? So this is the unit vector. So in the exam, if you write something like this, you haven't finished, make sure you move this number inside the angle brackets so you get the component form of the vector. Is that clear, everybody? Okay, good. Next, let's talk about the horizontal and vertical components of a vector U with magnitude. So this notation, I should use double absolute value. Okay, can be calculated by. Okay, so let's look at the picture. The U vector has 2 components, ux and uy. Okay, and when we draw the picture, let's say this is the vector u, and then can you see we can draw a line down there? We get a right triangle. Yeah, and this side is the hypotenuse, which is the magnitude of u. Hey, everybody, this is the magnitude of u. It's like the hypotenuse of the triangle. And then we have the component, the ux is the x component of the vector. And uy is the y component of the vector. Right, everybody? And we have the angle theta is here. Now, remember, what is cosine theta? Opposite, adjacent, hypotenuse. What is cosine theta? In terms of adjacent over hypotenuse. So adjacent over hypotenuse. Okay, what is adjacent? Yeah, adjacent is ux. What is hypotenuse? The magnitude of u. Right, everybody? So therefore, the ux is both sides multiply the magnitude of u. So it's the magnitude of u times cosine theta. Okay, everybody? Bless you. This picture is similar to what we had before. So if you can remember what we had before, we call this guy R, we call this guy X, and we call this guy Y. Yes. Okay. And then we have the X. Remember the unit circle is R cosine theta. And we have the Y is R sine theta. And in this case, we have similar picture where our r is like the magnitude of the u, our x is like the ux equivalence, and the y is like the uy. So therefore, we know sine theta is opposite over hypotenuse. Opposite is uy. Hypotenuse is magnitude of u. Therefore, uy is magnitude of u times sine theta. Is that okay, everybody? That's why we have this component form. Okay? Given your vector u, how do we find the component form? If you know the magnitude and the angle, then the x component is the magnitude of u times cosine theta. And then the y component is the magnitude of u times sine theta. Okay, everybody? So this formula is given the magnitude and the angle. We get this component form. Okay? So here, let's say we're given the magnitude and the theta. We can then write down the component form of the vector. Okay? But if a vector is given the component form, can we find the magnitude and the direction angle? By the way, the theta is called the direction angle. Okay? So given a component, how can we find the direction angle? Well, yeah, so look at tangent theta. So because the component form, this is ux, this is uy, and in this case, ux is like what? A, yeah, everybody? Uy is like B. Okay, and then, so tangent theta is what? Tangent theta is opposite over adjacent. Right, everybody? And opposite is uy, adjacent is ux. Therefore, you plug in uy is B, ux is A. Right, everybody? So you can think of like that. You don't have to relate it to the side and cosine. Just look at the picture. Opposite over adjacent. So we get tangent theta. Then what is theta? Well, we have 4 quadrants. Okay? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. But when you do arctangent of a number, do you remember what is the range of the arctangent? Exactly. Thank you. So the range the range of the arctangent function. So this is the tangent function, right? Of one period. And you know the range of the arctangent corresponds to the domain of the tangent. That's why it's minus pi over 2 to pi over 2, which covers, where's minus pi over 2? Here. And then this is 0. And this is pi over 2, right? So this range covers quadrant 1 and quadrant 4. Okay? But what happens if our angle theta is in quadrant 2 or 3? Then you need to add pi to it. Right, everybody? When you add pi to it, okay, this guy, when you add pi to it, you have something like this picture. So therefore, this is pi over 2, this is pi, this is 3 pi over 2, okay? Yes, when you add pi to it, then you get this guy. From pi over 2 to pi is a quadrant 2. Right, everybody? And this guy, pi 2, 3 pi over 2 is in quadrant 3. So you cover all the quadrants. Okay, so theta equals arctangent B over A if theta is in quadrant 1 and quadrant 4. It is arctangent B over A plus pi if the theta is in quadrant 2 or quadrant 3. So this is how do we find the direction angle. Plus the magnitude. We know the magnitude of u is gonna be square root a squared plus b squared. If we're given u is ab. Okay, everybody? So given magnitude and the direction angle, we can find the components form. The opposite, if we are given the component form, we can find the magnitude and the direction angle. So it's two-way process. And let's see examples. So we have example of both directions. So here, number 4, find the direction angle of the vector. So here we are given the components form and we want to find the direction angle. So part A, let's draw a picture. So always draw a picture, then you have an idea where this vector is, which quadrant it lies in. So 3, okay, 3 is positive, but then look at the y. Y is -4. See, you put a point there, and then you connect the origin to this point. This is the vector. Yes, everybody? Mm-hmm. And now, let's see. This is in quadrant 4. Right, everybody? This is in quadrant 4. Therefore, our theta is arctangent of b over a. You know, a is the x component, b is the y component. You are using the y component, -4 over 3. Is that okay, everybody? So if you want to draw the picture here, you can see, oh, tangent, opposite over adjacent. Opposite is -4. Adjacent is 3. Okay, everybody? So yeah, you if you want to think slower, tangent is opposite over adjacent. And you can see opposite is -4, adjacent is 3. And because we're in quadrant 4, then theta is the arctangent of -4 over 3. Now use your calculator. How many degrees? Like 4 decimal places? Thank you. Degree. Right, everybody? Yeah, if you use degree mode instead of radian mode, then when you add pi, you're not adding pi, you're adding 180 degree. Mm-hmm. So it depends on whether you use radian or degree. Okay, now you do part B. So everybody do part B. Draw the picture. Quadrant. Which quadrant do you get? Type B. 2. So what's your formula? You're gonna add 180 degrees to the angle. So it's in quadrant 2. Oh, did you add? Oh, no, yeah. Yes. Because if you don't add the 180 degrees, you'll be in. Okay, let's check our answers. See. Hey. Okay. So all of you have this picture. X is -2, the y is 3. Then tangent, opposite over adjacent. So 3 over -2. But because we're in quadrant 2, the theta is not just our tangent. You have to add 180 to it, plus 2. Right, everybody? If you do add tangent because it's negative, you will get quadrant 4. You need to add pi, so it lies in quadrant 2. Okay, everybody? Similarly, if I give you a point that is in quadrant 3, right? When you have quadrant 3, your x will be positive or negative? Negative. Your y will be negative. So your y over x will be positive. So add tangent of a positive number, your angle will be in quadrant 1. That's why you need to add pi, then it lies in quadrant 3. Is that clear, everybody? That's why our formula is like a piecewise formula. It depends on where the theta is. Okay? So make sure you draw the vector, then you can see which quadrant it lies in. Okay. This is number 4. So this is the direction angle. And you guys know how to find the magnitude. Right, everybody? Okay. So given the component form, you can find the magnitude and the direction angle of the vector. Okay, let's continue. Applications. So find the component form of the vector that represents the velocity of an airplane descending at a speed of 150 miles per hour at an angle of 20 degrees below the horizontal. So we have, this is the ground and an airplane here. Okay, I cannot draw a nice airplane. Wait, maybe like that. The circle. Okay, so it's descending. Okay, the speed is 150 miles per hour with the angle 20 degrees below the horizontal. We want to find the component form. Okay, everybody? So in this case, we know the magnitude of V. Let's say this is the vector V. Okay, this is the vector V. The magnitude of V is 150. And then theta. What is theta? 20. Wait, think about it. In our definition of theta, it is counterclockwise. We have positive measure. But this guy is clockwise. So what's your theta? Negative 20 degrees. Yes, everybody? Our theta is, this guy is theta. Okay? So this guy is theta. And quadrant 3 like that. And quadrant 4. If you rotate clockwise, your measure will be negative. So theta is negative 20 degrees. Then what is the component form? Okay, component form is magnitude of V cosine theta, magnitude of V sine theta. So 150 times cosine of negative 20 degrees. 150 times sine of negative 20 degrees. Yeah, we plug in the numbers, okay? So what is your answer? Give me 4 decimal places. What's 150 times cosine negative 20 degrees? 140.9. Thank you. That's the x component. How about the y component of the vector? Like that? Oh, 51. Okay. Thank you. Yes, everybody? So, this is the component form. And if you don't remember the formula, draw the picture. Draw the picture. This is the x component. So x component is like adjacent, right? Adjacent over hypotenuse is cosine theta. So you have magnitude times cosine theta first. The y component is the magnitude times sine theta. Is that clear, everybody? Mm-hmm. Okay, continue. Let's see here. An airplane is traveling at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude with a negligible wind velocity. When the airplane reaches a certain point, it encounters a wind with velocity of 70 miles per hour in the direction of north 45 degrees east. What are the resultant speed and the direction of the airplane? Okay, so let's draw some picture. Okay, let u be the airplane speed. Okay, and let v be the wind speed. Okay. How many of you take physics class? Yes. So have you seen speed and the component form of vectors? Okay, good. So let's see. Let's look at the airplane speed. So the airplane has let's see, 500. That's the speed, which is the magnitude, with the bearing of 330 degree. Okay, let's see. Did it say 330 degree? Oh, okay. So this is the north. Okay. 330 degree in this case it means we go clockwise 330 degree. So we get something like this. Okay, so this is the U, and that's the north direction. This is 330 degree. The bearing of 330 degree at a fixed altitude. Okay, so this is the same as saying, what is this angle? 30 degree, yes. So this is the same as saying north 30 degree west. Yes, everybody, north 30 degree west. Okay, because you go to the east, it's 330 degrees. This is the same as that. Okay, now we want to compute the vector component form of the U. Okay, how do we find the vector component form? Well, when you construct the component form, your theta is actually from the positive x-axis. Right, everybody? Your theta is actually from the positive x-axis to this angle, the terminal side of this angle. 120. Right? Okay, what is theta in this case? 120. Yes. So theta, look at this picture, is 30 degree plus 90 degree. So 120 degree. Yes, everybody? Mm-hmm. So our theta in definition is always from the positive x-axis. This is 90 degree plus 30 degree, 120 degree. Therefore, our u, what's component form again? Magnitude of u times cosine theta. Magnitude of u times sine theta. Okay, what is magnitude of u? 500. Cosine theta is 120 degree. Right, everybody? And the y component, 500 times sine theta. Okay. Cut this in your calculator. What do you get? Give me 4 decimal places. Oh, negative 250? Okay, so negative 250. How about the y component? 0127. Oh, 433.0127. Okay, thank you. Do you have the same answer, everybody? Mm-hmm. So this is the vector component form of the u, the airplane speed. Now let's take a look at the wind speed. Okay, let's use green color for the wind speed. So the wind speed, the magnitude is 70 miles per hour. In the direction north 45 degree east. So this is the vector v. Is that okay, everybody? North 45 degree east. Okay, so now let's figure out what is theta. Okay, this is like the x axis direction. If theta is 45. Actually, how do you compute? You are using 90 degree minus the 45 degree. That's why you get the 45 degree. Okay? Yes, everybody? Okay, if I give you this angle is 55 degrees, then what's your theta? If this angle is 55 degrees, yeah, 35. Right, everybody? Because they are, when you sum together, it's 90 degrees. How do you call those two angles? Complementary angles. Right, everybody? So you realize theta. Yeah, your theta. If we want to use this formula, your theta is always start from the positive x-axis. Okay? And therefore V. Alright. V is like same formula, the speed times cosine of the angle. The speed times the what? Sine of the angle. This is the velocity of the wind. Okay. Let's see. Oh, I just realized I have some mistake here. Usually speed, people say speed is the magnitude. It has no direction. So when you want to say it has a direction, you call it velocity. Okay, so let's call V is the wind velocity. The speed is the magnitude of the velocity. Is that okay, everybody? Like displacement. Displacement could be positive, could be negative, right? But distance is always greater or equal to 0. It has no direction. Okay? Similarly to velocity. Velocity may have direction. Okay? But speed is the magnitude of the velocity. Okay? Yes. Okay, thanks that. Now, okay, plug in your calculator. What is your first component? Thank you. And your second component? Oh, same thing. Yeah, which makes sense. You know what is cosine and sine 45 degrees? Root 2 over 2. Yes, so they're the same. Okay, wonderful. So now we want to find the resulting speed and direction of the airplane. So we add them together, right? So W is the resulting airplane velocity. It's gonna be U plus V. Yes, everybody? We add them, the airplane velocity and the wind velocity. We add them together. So let's see. We have U is what? Negative 250 and 433.0127. And we add the wind velocity 49.4975. 49.4975. Okay, what is the x component? Calculator, go up to that number and add that number. What do you get? Is I think it's negative. Yes. We add the first component. Okay. And then we add the second component. Remember factor operations, you calculate the factor. Minus 200 by what? Okay, minus 200.5025. Thank you. How about the y component? 400 and then what? 82 point. Thank you. Okay, everybody? So this is the resultant velocity. And now we want to find the speed and the direction of the airplane. Okay, look at this. What is this W? So W, if you want to draw the picture, you have the x component is negative. Okay, your y component is positive. So W is something like that. Can you imagine? This is the negative, and the x is negative, the y is positive. We are in quadrant 2. Yes, everybody? Quadrant 2. How do we find the magnitude? Square root of the first component square plus the second component square. Okay, give me 4 decimal places. What do you have? Sorry, louder. Thank you so much. This is the magnitude. Yeah, it kind of makes sense. Yeah, this number is bigger than 200 and bigger than 400. Hypotenuse should be longer. Right, everybody? And how do we find the direction angle theta? You know, tangent theta is the opposite over adjacent. Opposite is the y component, right? So 482.5102 over the x component, negative 200.5025. Okay, what is this? Give me 6 decimal places here. I know it's negative. Oh, okay. Yes. Oh, I'm just breaking it into 2 steps. Yeah, if you want to do the theta directly because it's in angle quadrant 2, your theta will be at tangent of that number plus 180 degree. And what do you get? How many degree do you get? 112.5649 degree. Thank you. Okay. Do you have the same answer, everybody? So this is the direction angle. Okay. But if the problem asks you, okay, I want you to express your angle in terms of the bearing, then what do you do? Okay. How do we find the bearing? Which is this piece. Okay. The bearing is this piece. Do you use this angle? What do you do? Let's call this is like alpha. Your alpha will be your theta minus 90 degree. Yes, everybody? Okay, what's this guy minus 90 degree? Is it 22.5649? So therefore, that's north. So our bearing is north 22.5649 degree west. Okay, everybody? So an airplane, they look at the bearing. Bearing, you always start with either north or south, and then east, west. Okay? So north, how many degrees east? Or north, how many degrees west? Okay, so that is application problems. Okay. Next topics, dot product. Okay. All right. So we have two vectors, u and v. Okay. The dot product is a number. Okay. So dot product is a number. It equals to, you use the first component of the vector u, multiply by the first component of the vector v, and then add the second component of vector u times the second component of the vector v. So you multiply each component respectively, and then add your answers together. Is that clear, everybody? So this is the definition of dot product. And you end up getting a number, not a vector. Okay. And this is some properties of the dot product. Okay. U times V dot product with V is V dot product U. So it's commutative. You can change the order of the vector. And zero dot product of anything is zero. because your one of the components are all zeros. That's why we can add them together. We just get 0. And it's also distributive. You can distribute the vector. And what is v dot v? Okay, think about it. V dot v. Okay, look at this. This is v. V dot v. You have v1 times v1 plus v2 times v2. Yes, everybody? Therefore, it's v1 squared plus v2 squared. And our magnitude of v is the square root of v1 squared plus v2 squared. Therefore, this is the magnitude of v squared. Is that okay, everybody? Dot product of the vector by itself equals to the magnitude of the vector squared. Okay? v1 times v1 plus v2 times v2 is that. How about if we have a constant multiple? Okay, then you can move the c with the u, or you move the c with the v, but do not move the c, both of them. Okay, it's like when you use like 3 multiplied by x times y. This is 3x times y, or 3 or x times 3y, but it's not equal to 3x times 3y. You cannot distribute because you get 9xy in this case. You can only distribute when you have a sum. Is that clear, everybody? Mm-hmm. Okay, so for a minute, let's do one example. So let u be the vector -1, 3, and v is the vector, and w is this vector. Okay, let's look at part A. So we can consider this is like 2 steps. The one step is we figure out what is u dot v, and we know this is a number. And then next step, we multiply by the w. So what is u dot v? -1 times 2 plus, yes. We multiply components respectively and then add them. -1 times 2 is -2. 3 times -4 is, so our answer is, exactly. This is the dot product. Yes, everybody get this step right? The dot product. And now second step, this is a number. So you use this number multiplied by w. So you have -14 multiplied by w. Okay, now you distribute. What is your first component? Yes. What is your second component? Yeah, positive 28. Right, everybody? Mm-hmm. This is part A. Now part B. U times 2v. Okay. U is -1, 3. Dot product 2v. What is 2v? Yes? So 2 times, yeah, so 2 times 2 is 4, and 2 times -4. Yeah, very good. The first step is to figure out what is 2 times v. Okay, everybody? And then, what is dot product? You use -1 times 4 plus 3 times -8. Okay, what is -1 times 4? -4, and then -24 is -28. Do you see this guy is double of -14? Yes, that is because u times 2v is 2 times u dot v. you can move the 2 in front, and you already have 2, that leaves. You can multiply by 2. Okay, everybody? So have a nice weekend. You can start working on your homework and practice exams. Okay. Yes. Have and if you miss some practice exam and exam correction and wrapper, please turn those in. Bye.
Yeah. You can always come in and we can do it in my office.